and then we can calculate the potential energy. Okay, so this basically concludes different kind of energies that we know. Kinetic energy calculated as half mv squared, and the potential energy, that is the gravitational potential energy, is calculated mgy. The y is the distance from the zero potential energy level, and the elastic potential energy or spring potential energy is calculated using half k x squared or half k delta x squared. Here k is going to be the spring constant. Okay. So now rest is basically doing some applications, and this is an example problem. A 200-gram block on a springless, on a frictionless surface is pushed against the spring with a spring constant 5 newtons per meter, compressing the spring by 2 centimeters. When the block is released, at what speed does it shoot away from the spring? Okay, so we usually do this kind of thing, right? So you compress the spring and let it go, so you can put something in front of the spring and press against it, and then the particle that you push against it, so it's going to move, right? So that's the question here. And initially, there is no any compression on the spring. So here our system, what is our system? It is not just the spring, okay? Spring and the mass, okay? If you consider just the spring, so you cannot solve the problem, okay? It is just the spring and the mass, okay? So we are talking about the kinetic energy of the mass and the potential energy of the spring. Okay? So what you are doing is that you are first doing some work, right? By doing some work on the system, you put potential energy into the spring mass system. Okay? That's what you do. You increase the potential energy. Then you let the spring mass system to convert its potential energy into kinetic energy of the mass. Okay? Clear? So that's what happened. So then before it is zero, there was no any kind of energy. So then, at the beginning here, so then now you can think about, this is the compressed spring, and compressed spring is having this much of potential energy now. Now it is converted into just, I'm thinking about the movement that you release your hand. Okay, at that point, so all the at the end, so when the spring is again comes back to the original length, so what really happens is that all the spring potential energy that was stored inside the spring now has been converted into kinetic energy of the mass. Okay, so initially it was compressed something like this. Now you release it. Then the spring comes to this point. When it comes to this point, spring is going to release the mass, and the mass starts moving with the calculated speed. Okay, so that's what happens. So if you do that, so you can calculate the speed, and what's going to be the speed when you calculate that. So E before is equal to E after, right? When you do that, E before is it's just the spring potential energy US plus there is no any kinetic energy. It's equal to before is initial and A initial and U is final plus A final. And the system here, mass plus spring. Okay. The system here, mass plus spring, and then on USI is what? Half k delta x squared plus 0. There was no any kind of initial kinetic energy. Is equal to USF. There is no any potential energy left when the mass starts moving away from the spring. Plus the kinetic energy final is going to be half mv final squared. Okay. So then these two halves cancel. So you end up with V final squared is equal to K over M delta X squared. So the V final now square root K over M delta X. Okay. So K is given here, 500 newtons per meter. And M is also given, it is 200 grams. 200 grams means 0.2 kilograms, right? It is 0.2 kilograms. And you get the square root of that multiplied by delta X. So delta X is 2 centimeters. 2 centimeters means 2 times 10 to the power minus 2 meters. Okay? Things must be converted into meters and kilograms. Okay? So if you work this out, so it's going to be, so what is the final answer? Just tell me what the answer is. Yeah. Huh? 1 meters per second. Okay. So this is basically the the other one is the elastic collisions. Elastic collisions, we did collision problems, right? We did collision problems, but we did not discuss collision problems with energy. Okay? When there is a collision, so let's say this is before they are going to have a collision, and 2 is at rest, and after the collision, both of them are moving to the right. Okay? And the initial kinetic energy of the system, here the system includes 1 and 2. And after the collision, we know that even before the collision and after the collision, total momentum remains the same, right? That is the momentum conservation. Irrespective of whether it is going to be an elastic or inelastic collision, the total momentum is conserved, given that there is no net force on the system. Okay? So here in this case, after the collision, not just the momentum, but the total kinetic energy is also conserved. Okay, so that's the definition of the elastic collision, and then if you solve the problem applying that, so we can find out the final velocities of these two after the collision. So these two are directly given to you, and if there is a problem, so you will be given this equation. Okay, otherwise that you can simply work it out and get it done. Okay. So now you should be able to do most of the problems in the Master in Physics homework, and there is one or two problems from oscillation. Okay, so I will discuss about oscillations Monday, and I will not have time to do any review, but I will do a review video and simply post that on YouTube. Okay, you can take a look at it. Okay, so I'll send you an email about it. And your final exam is a week after next Monday, right? 16. So that's the last phase, right? So you have enough things, but don't postpone everything. So even though it looks little that the content that we discussed a lot. Okay. Your final exam is going to be comprehensive, as I said. So things will come from everything what we learned so far. Okay. Yeah. be doing that for other class. So 26 hours. Okay. Because I don't have time to do review on Monday. Because I need to do something. All right. That's it. And if you have questions, please talk to me before the end of the semester. Okay. And I'll post